So in this lesson, we are going to focus on simplification of a force and couple system in 2 dimensions. Now, it is sometimes convenient to reduce a system of several forces and couple moments acting on a body to a more simplified form, that is by replacing it with an equivalent system consisting of a single resultant force acting at a specified point and a resultant couple moment. Now, this equivalent force system produces the same external effect on the body as the effect produced by the original force and couple moment system. Now, the external effects of the system refers to the translating and rotating motion of the body if the body is free to move, or to a larger extent, it refers to the reactive forces at the supports if the body is held fixed. Now, to clearly explain this, let's assume that we have 2 traffic lights hanging on a bar and then fixed at O. So we have the weight of the traffic lights to be W1 and W2. And the perpendicular distance from W1 to O is called D1. And that's between W2 and then O is also called D2. Now, the weights of the traffic lights W1 and W2 can be replaced by an equivalent resultant force such that we have WR, that is the equivalent resultant force, to be equal to W1 plus W2 and a resultant couple moment about O. So we want to take the moment about O, and then we have the resultant couple moment about O to be equal to, so we have the force times the perpendicular distance. So W1 times D1 plus W2 times D2. So this happens to be the resultant couple moment about O, and then we are taking the anticlockwise direction. Now, in this case, we can represent what we've done here as having a resultant force, that is an equivalent resultant force WR, and a resultant couple moment MRO about point O. So basically, what we are trying to say is that given a system of several forces and couple moments acting on a body, we can replace that with an equivalent system consisting of a single resultant force, in this case WR, acting at a specified point O, and a resultant couple moment. Now, in this lesson, we are going to solve 3 examples. This happens to be our first example. Let's try to solve this example. So for question 1, replace the loading system by an equivalent resultant force and couple moment acting at point A. So let's try to solve this together. Now, we have 3 forces here. Let's consider this to be F1. Let's consider this to be F2, and then this to be F3. So for F1, we have 100 pounds, F2, that is 200 pounds, and then F3 is 150 pounds. Now you realize that F2 is acting horizontally, F3 is acting vertically. However, we need to resolve F1 into its X and Y components. And so we have this to be F1Y, and then this to be F1X. So how do we find F1X and then F1Y? So you realize that we have a triangle. This forms a triangle, and the line of action of F1 passes through this line. And so if you have this to be 3 and this to be 4, then it's basically a 3, 4, 5 triangle. So the hypotenuse is 5 feet. Now, F1y corresponds to 4 feet, and then F1x corresponds to 3 feet. And so if you want to find F1x, then this is equal to nothing but 3 over 5 times 100. Now, if you should evaluate this, then you obtain 60 pounds. And then for F1y, that is also equal to, you have 4 divided by 5, also times 100, and that is equal to 80 pounds. So this is F1x, F1y. Now let's focus on F2. Since F2 is acting horizontally and then moving into the point where you want to take the moment about, then it means that F2 can be said to be F2x because it acts only horizontally, and since it is moving into the point, you have a negative value. So this becomes negative 200 pounds. So you can think of it as, if you have the force moving horizontally away from the point, then you have a positive value. If it is moving into the point, you have a negative value. If you have an upward force, that is positive. A downward force is negative. Now let's move on to F3. So also for F3, you realize that the force is acting vertically downwards, and so you have a negative value. So that is going to be F3y, negative 150 pounds. Now, having gotten the force components along the x or y axis, let's try to find the sum of Fx and then sum of Fy. So for sum of Fx, that is equal to, we have F1x plus F2x. And that is equal to, F1x is 60, F2x is negative 200. When you sum up the two, you have negative 140 pounds. Also for sum of Fy, you are going to have F1y plus F3y, and that will be equal to 80 plus negative 150, and that is equal to negative 70 pounds. Now, you have the x value to be a negative value. It means that from point A, you are moving along the negative x-axis. So this is Fx. You also have a negative value for the y component. So that's going to be lying on the negative y-axis, and this is Fy. And then you have the resultant force acting somewhere here, and you have the angle theta always formed between Fr and then Fx. So let's find Fr, that is the resultant force, and the angle theta. So Fr is equal to the square root of negative 140 square plus negative 70 square. When you simplify this, you obtain 156.52 pounds, and then you have the angle theta to be equal to tan inverse of Fy over Fx. Now this is equal to tan inverse of, now at this point you are going to neglect all negatives, so you have 70 divided by 140, and that will give you 26.57 degrees. So having found the values of Fr and then theta, next we are going to find the resultant couple moment acting at point A. So we have resultant couple moment Mr of A to be equal to, So basically we are going to consider the forces F1y, F1x, F2, and then F3. We are going to find the moment about point A. So for F1y, we have the line of action extending through to this point. Therefore, we need to move in the anticlockwise direction. Now, anticlockwise moment becomes negative, and then clockwise moments are positive. And so we are going to have a negative value for F1y. So that is negative 80 times perpendicular distance 3 plus 3 from A is 6. Then you move on to F1x. This is the perpendicular distance 4 feet. So you are going to move in the clockwise direction. So plus 60 times 4. Now for F2, the line of action of F2 passes through A. So the moment about A is 0. And then for F3, you have the perpendicular distance to be 3 feet. And so you are going to move in the clockwise direction. So that is still a positive value. So plus 150 times 3. Now let's simplify this. So negative 80 times 6 is negative 480 plus 60 times 4 is 240 plus 150 times 3 is 450. Now when you add all three values, then you obtain 210 pounds feet. So this is the moment or the resultant couple moment about point A. And since we had a positive value, it means that the resultant couple moment is taking the clockwise direction. If it is negative, then it means it is anti-clockwise. Now let's move on as we solve two more examples. Also for question 2, we are going to replace the loading system by an equivalent resultant force and couple moment acting at point A. So quickly, let's call this F1, F2, and then F3. Now F1 and then F2 are acting vertically downwards. So we have this to be F1 equals 40 newtons, F2 30 newtons, and then we have F3 to be 50 newtons. Now, since F1 and F2 are acting vertically downwards, then we say that they are the y components. And so we have F1y to be a negative value, which is negative 40. And then we have F2y also to be negative 30 newtons. Now for F3, we need to resolve F3 into its x and y components. So we have this to be F3x and then F3y. So for F3x, now F3x corresponds to 4. And so that's going to be 4 divided by 5 times 50. 5 goes here once, 5 goes here 10 times. So that is equal to 40 Newton. And then for F3y, F3y corresponds to 3. So that becomes 3 over 5 times 50. And that is equal to 30 newtons. Now let's try to find the sum of fx and then sum of fy. So for sum of fx, that is simply equal to f3x, and that is equal to 40 newtons. And then for sum of fy, that is equal to, we have f1y plus f2y plus f3y. Notice that all of them are acting vertically downwards. All of them are acting vertically downwards, and so you are going to have this to be a negative value because f3y is also acting vertically downwards. so it becomes a negative value. And so you are going to have negative 40 for this plus negative 30 for this, and then plus negative 30 also for this, and that is equal to negative 100 newtons. Next, let's find FR. So we have FR to be equal to the square root of 40 square plus negative 100 square, and that gives 107.70 newtons. And then for the angle theta, we have tan inverse of Fy, so 100, we neglect the negative, divided by 40, and that is also equal to 68.20 degrees. Now at point A, we had Fx to be positive, so that is acting along the positive x-axis, and then Fy to be negative, so along the negative y-axis. So we are going to have Fr acting somewhere along this line, and we have this to be the angle theta. So we have the equivalent resultant force to be 107.70 newtons. Now let's find the resultant couple moment acting at point A. And so we consider the forces F1, F2, F3x, and then F3y. So the resultant moment about point A is equal to, so for F1, the line of action of F1 is through A, and so the moment about A is 0. Now for F2, we have F2 to be 30 newtons, and then it's moving in the clockwise direction. So the perpendicular distance is 3 meters. Therefore, we have 30 times 3 plus. Now for F3y, F3y is also acting along this line. F3y is acting along this line, and so you have F3y also moving in the clockwise direction. So F3y times 3 plus 3, which is 6. So you are going to have plus 30 times 6, 3 plus 3. Now you come to F3x, and the line of action of F3x passes through A. So the moment about A for this force is 0. And then we have moment 200 Newton meter moving or taking the clockwise direction. So we add that to this, and then we have plus 200. Now let's simplify this. So we can add 3 and then 6 to get 9, and then we have 30 times 9, which is 270. So 270 plus 200, and that is equal to 470 Newton meter. Since we have a positive value, it means the resultant couple moment is taking the clockwise direction. Now let's move on as we solve the last example. Now to the last example, we are going to replace the loading system by an equivalent resultant force and a couple moment acting at point A. Now let's consider this to be F1 and then this to be F2. So we have F1 to be 900 newtons and then F2 300 newtons. Now let's resolve F1 into F1x and then F1y. So we have this to be F1y and then this to be F1x. So for F1x, that's going to be 900 sine 30. So 900 sine 30, and that is equal to 450 because sine 30 is half, and then F1y is also equal to 900 cos cos 30, and that is equal to 779.42 newtons. Now, because it is acting vertically downwards, then it becomes negative. Also for F2, we have F2 acting vertically downwards, and so this happens to be the vertical component. So that becomes F2y, and that is equal to negative 300 newtons. Now let's find sum of Fx, and that is equal to, we have F1x. So that is equal to 450 newtons, and then sum of Fy, that's going to be F1y plus F2y. So we have F1y to be negative 779.42 plus F2y negative 300, and then when we sum up these two values, we have negative 1079.42 newtons. So next, let's find Fr equals the square root of 450 square plus negative 1079.42 square. So when you simplify this, then you obtain 1169.46 newtons, and then you have theta to be equal to tan inverse of Fy over Fx. So positive of Fy over Fx 450, and that is equal to 67.37 degrees. So we had Fx to be positive, so moving along this line, that is Fx, and then Fy to be negative, also moving along this line. We have this to be Fr, and then this to be theta. So now let's move ahead and find the resultant couple moment acting at point A. So for this, we are going to consider the forces F1y, F1x, and then F2. Now we are also going to consider all the forces to be positive, except that we are taking an anticlockwise moment. Now for F1x, you realize that the line of action of this force passes through A, therefore the moment about A is 0. Now for F1y, we are going to take the clockwise direction. This is the force and this is the perpendicular distance, 0.75. So we have F1y as 779.42 times 0.75 plus, now for F2 we have 300, and then it's also going to take the clockwise direction, so we are going to add 0.75, 0.75, 0.75, and that will give 2.25. So we have 300 times 2.25, and then lastly we have moment taking this time the anti-clockwise direction, so that becomes negative, so negative 300. Now let's simplify this. So 779.42 times 0.75 gives 584.6 plus 300 times 2.25, that gives 675, and then minus 300. Now when you evaluate this, then you have 959.6 0.6 Newton meter in the clockwise direction. Now you can simplify this as approximately equal to 960 Newton meter. So that's it for today's video. Thanks for watching and see you in my next video. Bye bye.